Let's continue with the sample problems on section 7.2, and I'm working from page 303 in our textbook, and I'm going to begin with a mixture problem. If you'll take a glance at the problems on the page, you'll notice 39 and 40 have tables that are already set up, and what we're going to do is kind of mimic those tables. We're talking about a medicated first aid spray that contains alcohol. So we want our table to show strength. That's going to be the percentage. The liters of solution. And then the liters of alcohol, since we're talking about the amount of alcohol in the first aid spray. Now let's read through the problem. A medicated first aid spray on the market is 78% alcohol by volume. If the manufacturer has 50 liters of the spray containing 70% alcohol, how much pure alcohol should be added so that the final mixture is the required 78%? And they give us a hint that pure alcohol is 100%. So we have 50 liters. 50 liters, that's 70% alcohol. So 0.7 times 50. Notice what we're doing is we multiply these two to equal the third column. So we're going to get 35 actually when we multiply that out. Now we're adding pure alcohol, which is 100%. And we don't know how much we're adding, but what we're going to end up with is 1.0 times x, or 1x, when we multiply that. Now the end result, we want to end up with 78% alcohol. Okay, and that's going to be the 50 we started with plus the x liters of alcohol. So we're going to have 0.78 times 50 plus x. So how do we build our equation? Well, our equation is going to come from the last column. What we note is that the alcohol in the original solution plus the pure alcohol, which is all alcohol, should equal the amount of alcohol in the final solution. So we have 0.7 times 50 plus x equals 0.78 times 50 plus x. So we know that's 35. And we want 0.78 times our 50. It's 39 plus 0.78x. Okay, so we want to subtract, get our x's together. And remember, this is a 1 in front of the x. So we're going to get 35 plus 0.22x equals 39. We subtract 35. 0.22x equals 4. That means when we divide by 0.22, we'll get x. 4 divided by 0.22 is 18.18 repeating. That's 211ths, which is 18 and 18 times 11, it's 198, if you write it as a fraction. Okay, so liters for either of these answers. Okay, the book is giving it in this form. All right, so that was a pretty big problem. It actually took up a whole page. Okay, so let's move on to an investment problem. Okay, and we'll do 48 for this one. And again, if you'll notice, you have some sample tables that have been done in numbers 45 and 46. You want the rate as a decimal, the principal, and then the interest in 1 year. Rate, principal, interest. And as I mentioned, usually in business, I equals P times R times T. The time in all of these is 1 year, so they're kind of ignoring time, and that's simply because the time is 1. D.D. Myers invested some money at 3.5% simple interest. And 5,000 more than 3 times the amount at 4%. Okay, so she's got X dollars at 3.5%, 5,000 more than 3 times the amount. Okay, so that's how much she's got at 4%. How much did she invest at each rate if she earned 1,440 in interest? So her total interest is 1,440. Okay, so the interest is going to be, we want to do this as a decimal when we compute, so .04, and this one would be 0.4 times our 3x plus 5,000. Okay, so what do we know? Well, the interest earned on the one account at 3.5% plus the interest earned on the account at 4% is going to total 1,440. So that's where our equation comes from. Plus 0.4 times 3x plus 5,000 equals our 1,440. And that's going to be 1.2x plus 0.4 times 5,000 is 2,000. Plus equals 1,440. So 1.2 plus our point, that should be a 0.04. Okay, so that's going to be 0.04. Let me erase this to make sure alright, so sorry about that. It should have been 0.04. I had it right over here and then I did it wrong there. Okay, so we want to combine those two. So 0.12 plus 0.035 is 0.155x. And this should be 200. Equals 1,440. Now we want to subtract the 200. I think I finally straightened everything out. 0.155x equals 1,240. Divide by our 0.155 to get 1x. Okay, 1,240 divided by 0.155 is $8,000. at 3.5%. And that means she had 3 times that would be 24 plus 5 be 29,000 at 4%. And that comes from sticking the 8,000 into the equation we have here, or the expression I should say we have there. Okay, let's see if we can work one more in here. Let's do a distance problem. That means rate, time, and distance. And we'll be working on number 66. And in 66, Jeff leaves his house on his bicycle at 7:30 a.m. and averages 5 miles per hour. His wife Joan leaves at 8 a.m. following the same path and averages 8 miles per hour. At what time will Joan catch up with Jeff? So we have Joan. Let's do Jeff first since he's listed first. We have Jeff. And we have Joan. Jeff is going 5 miles per hour and Joan travels at 8 miles per hour. So what we know about the time is that Jeff leaves an hour, let's see, 30 minutes before Joan leaves. So if Jeff travels X, Joan is traveling X minus a half an hour. Actually, and I'm thinking, okay, I'll just leave it as a fraction. So here's our distance covered by each. Now, what's happening? They're both starting from the same point, and they're both following the same path. So there goes Jeff, and Joan is cycling faster, so eventually she's going to catch up to him. So they will have traveled the same distance. That's what we can see from the picture. So that's what we need to do, is set this up so that the two distances are equal. And if we distribute the 8, we'll get a 4. Half of 8 is 4. And so if we subtract 8x and divide by -3, we get x is a positive 4/3. So that would be 4/3 of an hour. Okay, and so that's an hour and a third. So from the time that Jeff leaves, okay, Jeff left at 7:30. So an hour and 20 minutes, third of an hour, 1/3 of 60 is 20 minutes. So an hour and 20 minutes, that's going to be 8:50 a.m. So notice that our x is not the answer to the question because they want to know what time does Joan catch up with him, and it would be at 8:50 a.m.